Alright, hello. Hello. This is going to be Solidworks CSWA practice problem 9.10. And if you want to follow along with the video, make sure to follow the link in the description. That'll take you directly to the official Solidworks practice problem database. So let's get started. First of all, we're in assembly, and the units for this are going to be in IPS, which is inches, instead of the normal MMGS that we use for parts. So switch it to IPS. So let's insert our base component. It says insert crankshaft at the origin, so we're going to get the crankshaft. Here's the crankshaft. And one important thing to realize is that you need to rotate the view of this part so that it matches the isometric view. So we're going to have to rotate it, I believe rotate it around the Y. So go to the bottom left corner and say rotate component about Y, and then it should look like this. And then we'll just click the green check mark at the top to fix at the origin. There you go. So that's fixed in the right orientation. And then we're going to select insert components, and let's get some parts in here. So let's get our piston head. Let's get our lower connecting rod, and then let's get our upper connecting rod. And then let's copy and paste each of these three parts so that we have two of each. Just Control-C, Control-V. Okay. So the two locations where we're going to be making are the two locations where the connecting rods are going to be concentric with are going to be this cylinder right here, and then this cylinder right here. Not the first one, ignore that one, just these two. So first of all, let's start with the lower connecting. So let's start our mates. I'm going to select the cylindrical face, this cylindrical face, select OK. And then let's make sure that the width of this lower connecting part is perfectly centered between these two faces. So I'm going to go to Mates, Advanced, and then Width. And then the first width selection will be lower connecting part. Second width selection will be between these two faces, and it should center it like so. It'll say centered underneath constraint. You'll select OK. And then I'm just going to repeat this same process for the other parts. So, sorry. I was still in the advanced tab. Need to switch back to standard. So let's make these concentric. Then let's center its widths. So with the center between these two faces, and select OK. And because these two lower, and the reason why they're called lower connecting is because they're supposed to be on kind of the underside of the cylinders, the underside. So we'll flip them more or less like that. And then the reason these are called uppers is because they're the ones that are going to kind of finish the circle. That's why this is kind of like a half circle shape. So it's going to finish the circle, and all we need to do is make these side holes concentric. So this right side hole is going to be concentric with the right side hole of the lower connecting rod. So make them concentric, select OK. And then, well actually I guess I should have done this first. I guess I should just made them, or this cylindrical underside and then this cylinder, make them concentric. I mean, it works this way too, but it's makes a little more sense if you do the concentric constraint first and then the concentric constraint for the holes. So now when you rotate them, they rotate together. kind of like a Lego piece. So I'm going to copy the same thing for the other side. So under cylinder to cylinder, concentric. And let me pull this over here. And then the respective holes are concentric. There we go. Okay, so now we just gotta get the pistons in. So let's make the whole of the piston concentric with the whole of the upper connecting rod. And then if you look inside, there seems to be a gap, a small gap between the upper connecting rod and the gap inside of the piston. So we're gonna have to use width to properly center it. So I'm gonna advanced and width. And at first I'm gonna select this as the first width, and I'm going to center that cylinder between these two faces and the inside of the piston, and boom, perfectly centered. Select OK. And you see that's there's like a little gap between the upper connecting rod and the cylindrical faces of the piston. So we're going to copy that same thing for the other piston. First switch back to standard so we can get the concentrics in. Let's make them concentric. Then switch to advanced, click width. Then let's center this width between this width inside the piston. Select OK. Okay. So from here, I'm gonna make my view perpendicular to this face. And for here, we're gonna have to enable the planes of the pistons. So I'm gonna click on each piston. I'm going to the I believe it's called a feature tree. Yes, the feature design tree. I'm gonna right click on the piston parts, and I want to show its planes. Let me see where that is. How do I show its planes? Oh, reference geometry? Oh, here it is, okay. So if you right click the part in the feature design tree and you go to reference geometry display, and then you hover over it, it'll show you the option for show primary planes. Show primary planes. Thought I clicked it. Let me click that again. Show primary planes. Let me click it again. Wait, reference geometry, show primary planes. Oh, there it is. Oh, I just don't have my plane view enabled. Oh, there it is. Okay. Okay, so now I have my plane views enabled. So here we go. So then, what was I doing? Oh yes, now the angle. Well, I also want to show the main planes as well. So I'm going to show primary planes of the entire part. And then we're going to go to mate. Actually, first of all, let me center back into my view. Actually, no, I'm not. So, okay. So now we have plane view enabled for the pistons and then the main part. So I'm going to click Mate. Let's make an angle constraint of 160 degrees. And the constraint is going to be between the right plane of the fixed part at the origin and the right plane of the piston. So we need to flip the alignment, flip the dimension, and that should be correct. Should be correct. It looks correct. Yes, it looks correct. So we'll select OK. And then I'm going to hide my primary planes, but still keep the piston planes enabled. So now I can move it like this. So if you look from this front view of the original part, or actually if you look at the front view in the engineering drawing, you'll see that the two pistons from this view are like kind of sitting on top of each other. So we're going to click Mate. And I think the first thing I'm going to do is I'm going to make their top faces coincident with each other. Actually, no, I don't want them to be coincident. I want them to be parallel. I want them to be parallel to each other. The top faces, I want them to be parallel to each other. So I'm going to select OK. And then I think what I want is I want their right planes to be coincident with each other. So let me select the right planes. I'm going to make them coincident with each other. And then now it looks as if they're kind of stacked on top of each other like this. But of course I can still rotate the part like this. I mean, this right here should be about where the view orientation is. It looks like I need to fix the parts. Maybe I need to oh wait, actually, oh yes. In section AA view, there's one constraint that I missed. So I'm going to enable my primary planes again for the fixed part. I'm going to click Mate. I'm going to select the right plane. And then I'm going to select this face right here, this side face of the fixed, or of the crank, or crankshaft. And I'm going to make sure they're parallel to each other, like this. So that face should be parallel with the right plane. So I'll select OK. I don't think that fixed the problem. Yes, it can still rotate like this. Still rotates. So obviously there needs to be some sort of angle dimension for the upper connecting rod, correct? I would assume so. From what I'm seeing, it appears to me that this upper connecting rod right here, the second one, not the first one, I think the axis or the right plane of this connecting rod is also 160 degrees constrained from the right plane of the fixed part. I mean, just judging from the I believe that's the front view. Judging from the front view, whichever view has the 160 degrees, it seems like the second connecting rod is like kind of perfectly aligned with that diagonal line. So I think that's the answer. So I'm going to that specific connecting rod, the upper connecting rod. I'm going to right click, go to reference geometry display, click show primary planes, and then I'm going to click view planes, and there's the planes for those upper connecting rods. Let me enable my main plane view. And then let's add that mates, the angle mates, which is 160 degrees between the right plane of the fixed part and then the right plane and then the right plane of the connecting shaft, of the upper connecting shaft, which will be this. I'm trying to select it. This plane right here. And if I hover over it, it'll say right plane of upper connecting rod. So I'll click that. I'll say 160 degrees. I think we need to flip the mate alignment and then flip its dimension. And then we'll select OK. Select it out here, and I'll hide all my planes. So let's go back to the front view. And now I can't rotate it. It's perfectly in place. And it looks exactly like the front view drawing. Yep, can't move it, trying to rotate it, cannot move. The entire part is perfectly fixed. So that should be it. Okay. So now all we need to do is check the answer. So let's go to evaluate, mass properties, and then what are we looking for? Looking for center of mass in inches. So let's go to center of mass. So for my center of mass, my x is 0.59, my y is 1.33, and then my z is negative 6.73. I'll repeat that again. So the x is 0.59, the y is 1.33, and the z is negative 6.73. So I hope you learned something from this video, and I'll see you in the next one. So thank you for watching.